Wilhelm Conrad Röntgen, German, VLHLMN. The 27th of March 1845 to the 10th of February 1923, was a German physicist, who, on the 8th of November 1895, produced and detected electromagnetic radiation in a wavelength range today known as X-rays or Röntgen rays, an achievement that earned him the first Nobel Prize in Physics in 1901. In honor of his accomplishments, the International Union of Pure and Applied Chemistry, IUPAC, named element 111, Röntgenium, a very radioactive element with multiple unstable isotopes, after him. Biography. In 1865, he tried to attend the University of Utrecht without having the necessary credentials required for a regular student. Upon hearing that he could enter the Federal Polytechnic Institute in Zurich, today known as the ETH Zurich, he passed its examinations, and began studies there as a student of mechanical engineering. In 1869, he graduated with a Ph.D. from the University of Zurich. Once there, he became a favorite student of Professor August Kundt, whom he followed to the University of Strassburg in 1873. Birthplace of Röntgen in Röntgen. Career. In 1874 Röntgen became a lecturer at the University of Strasbourg. In 1875 he became a professor at the Academy of Agriculture at Hohenheim, Württemberg. He returned to Strasbourg as a professor of physics in 1876, and in 1879, he was appointed to the chair of physics at the University of Gießen. In 1888, he obtained the physics chair at the University of Würzburg, and in 1900 at the University of Munich, by special request of the Bavarian government. Röntgen had family in Iowa in the United States, and at one time planned to emigrate. Although he accepted an appointment at Columbia University in New York City, and had actually purchased transatlantic tickets, the outbreak of World War I changed his plans and he remained in Munich for the rest of his career. During 1895 Röntgen was investigating the external effects from the various types of vacuum tube equipment, apparatuses from Heinrich Hertz, Johann Hitnoff, William Crookes, Nikola Tesla and Philip von Leonard, when an electrical discharges passed through them. In early November, he was repeating an experiment with one of Leonard's tubes in which a thin aluminium window had been added to permit the cathode rays to exit the tube, but a cardboard covering was added to protect the aluminium from damage by the strong electrostatic field that is necessary to produce the cathode rays. He knew the cardboard covering prevented light from escaping, yet Röntgen observed that the invisible cathode rays caused a fluorescent effect on a small cardboard screen painted with barium platinum when it was placed close to the aluminium window. It occurred to Röntgen that the Hitnoff-Crookes tube, which had a much thicker glass wall than the Leonard tube, might also cause this fluorescent effect. In the late afternoon of the 8th of November 1895, Röntgen determined to test his idea. He carefully constructed a black cardboard covering similar to the one he had used on the Leonard tube. He covered the Hitnoff-Crookes tube with the cardboard, and attached electrodes to a Ruhmkorff coil, to generate an electrostatic charge. Before setting up the barium platinum screen to test his idea, Röntgen darkened the room, to test the opacity of his cardboard cover. As he passed the Ruhmkorff coil charge through the tube, he determined that the cover was light-tight, and turned to prepare the next step of the experiment. It was at this point that Röntgen noticed a faint shimmering from a bench a few feet away from the tube. To be sure, he tried several more discharges, and saw the same shimmering each time. Striking a match, he discovered the shimmering had come from the location of the barium platinum screen he had been intending to use next. Röntgen speculated that a new kind of ray might be responsible. The 8th of November was a Friday, so he took advantage of the weekend to repeat his experiments and make his first notes. In the following weeks he ate and slept in his laboratory as he investigated many properties of the new rays he temporarily termed X-rays, using the mathematical designation for something unknown. The new rays came to bear his name in many languages as Röntgen rays, and the associated X-ray radiograms as Röntgenograms. At one point, while he was investigating the ability of various materials to stop the rays, Röntgen brought a small piece of lead into position while a discharge was occurring. Röntgen thus saw the first radiographic image, his own flickering ghostly skeleton on the barium platinum screen. He later reported that it was at this point that he determined to continue his experiments in secrecy, because he feared for his professional reputation if his observations were in error. Röntgen's original paper, on a new kind of rays über eine Art von Strahlen, was published on 28 December 1895. On 5 January 1896, an Austrian newspaper reported Röntgen's discovery of a new type of radiation. Röntgen was awarded an honorary Doctor of Medicine degree from the University of Wurzburg after his discovery. He published a total of 3 papers on X-rays between 1895 and 1897. Today, Röntgen is considered the father of diagnostic radiology, the medical specialty which uses imaging to diagnose disease. Personal life. Röntgen was married to Anna Bertha Ludwig, M. 1872, D. 1919, and had one child, Josephine Bertha Ludwig. Adopted at age 6, in 1887, she was the daughter of Anna's brother. Röntgen died on 10 February 1923 from carcinoma of the intestine. It is not believed his carcinoma was a result of his work with ionizing radiation, because of the brief time he spent on those investigations, and because he was one of the few pioneers in the field who used protective lead shields routinely. Röntgen did not take patents out on his discoveries, and donated the money for his Nobel Prize to the University of Wurzburg. With the inflation following World War I, Röntgen fell into bankruptcy later in life, spending his final years at his country home at Wilhelm, near Munich. In keeping with his will, all his personal and scientific correspondence were destroyed upon his death. Honors and awards. In 1901, Röntgen was awarded the very first Nobel Prize in Physics. The award was officially in recognition of the extraordinary services he has rendered by the discovery of the remarkable ray subsequently named after him. Röntgen donated the monetary reward from his Nobel Prize to his university. Like Pierre Curie, Röntgen refused to take out patents related to his discovery, as he wanted mankind as a whole to benefit from practical applications of the same. Personal statement. Practical applications of the